Hello, this is Ms. DB, and in this video I'm going to show you how to do some of the proofs from the More Proof Practice worksheet in the Week 6 folder. This has to do with both sections 2.6 and 2.7. So the first thing that we need to do is talk about what a theorem is, because we want to be able to prove theorems in this lesson. A theorem is any statement that you can prove. Once you've proven a theorem, you can use it as a reason in later proofs. We're going to prove some theorems today that we will then even use in proofs today. So the first one is a linear pair theorem. That just says that if you have two angles that form a linear pair, like these two, angle 1 and 2, or angle A and B, to match what this says, then they also are supplementary, which would mean that they would add up to 180 degrees. We're going to do number 3 today, which will prove that theorem. Another theorem that we're going to do is the congruent supplements theorem. So that says that if two angles are supplementary to the same angle, and supplementary means that they add up to 180 degrees. So in this example, angle 1 and 2 are supplementary. And then I have another angle, let's call this angle 3, and angle 3 and angle 2 are also supplementary, that they add up to 180 degrees, then the two angles are congruent. And we'll prove that with number 5. Also, we have the right angle congruence theorem. This is a nice little tiny theorem that just says all right angles are congruent. I'm not going to prove that theorem, and you're not going to either, but it's in your book on page 112, so you can go and check the proof. And there's no steps in our proof that we wouldn't be able to do ourselves. Just for the sake of time, we're just going to let that one be proven on page 112. The congruence complements theorem, you already proved that. In your last worksheet on number 5 on 2.6 worksheet, you actually proved one case of the congruent complements theorem, which says that if you have two angles that are, whoops, that is off a little bit, two angles that are complementary to each other, remember that that means that they add up to 90 degrees, just 90, not 190. So here's two angles that are complementary, so they add up to 190. And let's say that there's another angle over here, angle C, and angle C and angle B are also complementary. Then that means that angle A is congruent to angle C. All right, I'm going to just kind of go through. This is an example of a proof that you might see on a worksheet or on a quiz, and it's missing some stuff. So I'm just going to go through some kind of hints, and this is on your worksheet, so you can always look back and say, wait a minute, how did we do that? So we are going to look at this diagram here of these lines, and we're going to prove that measure of angle 1 is equal to the measure of angle 4. Now, this is one way of proving that vertical angles are congruent, but we'll get to that later on in this lesson. So we are given a lot of things. We're given that measure of angle 2 is equal to the measure of angle 3, and they're already marked with one little angle mark. Measure of angle AXD is congruent to the measure of angle AXC, and we need to prove that measure of angle 1 is equal to the measure of angle 4. All right, first step. They wrote down the statement already. Measure of angle AXC is equal to the measure of angle AXD. Look at that's right here. That's a freebie. That's almost always going to be given. So you need to write the word given there. Okay, now I'm not going to, there is another given, measure of angle 2 equals measure of angle 3, and I'm going to use it later, but right now I'm going to think about what that means. AXC. Well, measure of angle AXC is made up of two things being added together. So they're telling me, let's use the angle addition postulate and write what those two things are. So measure of angle AXD is equal to, I'm supposed to be looking at this one first, is equal to the measure of angle, look, 1 plus the measure of angle 2. We could call them AXE and EXD, but they're already numbered that way, so that's even easier, less to write. All right, now we got to do the same thing for step 3, which is the measure of angle AXC. We're going to use the angle addition postulate again, and this time it's angle 3 plus angle 4. would equal measure of angle AXC. Now let's look back here. The next step, step 4, is measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. Well, look, that's what we added. I'm going to change color here. That's what we added together. Measure of angle 1 plus measure of angle 2. And then we have measure of angle 3 plus. How did we put these two together? Well, because the first statement says that measure of angle AXC equals measure of angle AXC. So then we just took measure of angle AXD and I replaced it with what it's equal to, measure of angle 1 plus measure of angle 2. And then I took the measure of angle AXC and I replaced that with what it's equal to, which was measure of angle 3. So I used what property there? I used the substitution property. I substituted in what they were equal to, and that's what I got then. Now let's see, they wrote measure of angle 2 equals measure of angle 3. Wait, that was part of my given. So you'll write given here. Even though it's later on, you don't always have to write all the given at the beginning. You could have, but this is where I need it, so this is where I wrote it. Now, let's see. There's a hint down here. It says look at lines 4 and 6. 4 and 6. They're almost exactly the same, but they want me to change this to something else. What should we substitute it for? Well, I know that measure of angle 2 is equal to the measure of angle 3, so I'm going to plug that in, and that's the substitution property of equality. Okay, my very last step is I took measure of angle 1 plus measure of angle 3 equals measure of angle 3 plus measure of angle 4. I have the measure of angle 3 on both sides of the equal sign. So I can subtract it from both sides of the equal sign, and I'll end up with my final step, which is what I wanted to prove, and this is the subtraction property, because that's what I did. I subtracted, so it's the subtraction property of equality. So then what you should do is look at your worksheet later and see if you can remember these steps, or you don't have to remember them, you just have to be able to figure them out. Work with the clues that you're given to try to figure out the missing parts. All right, now we're going to try some proofs. Now, I'm not going to do all of these for you because this is your assignment, but I'm just going to, especially like on number 3, look at that one because that one is a proof of a theorem that we're going to be able to use. So I think you'll be able to fill in number 1 on this. Remember what your freebie is. And there's a hint here that in step 3, what segment could you use the segment addition postulate with? So, for example, segment DE, there's no parts in it. It's just one segment. So I can't use the segment addition postulate. But in the other segment, segment FH will be made up of 2 parts added together. So for step 3, you're going to write the equation of what 2 parts added together will equal the whole thing. And then in step 4, you might be able to say, well, wait, DE is equal to FH, so maybe I'll be able to substitute something. So try that one and see how that goes. Okay, I'm going to help you out starting angle or problem number 2. So we have this triangle, and it says that segment AD bisects angle BAC, which means that angle 1 is congruent to angle 2 because of the definition of angle bisector. We're going to use that in the proof. We're also given that angle 1 is congruent to angle 3. That's part of our given. So you have 2 things to write down for your given. You can write them both on separate lines. So that'll take up 2 steps of your proof. The third step is you're going to use the definition of angle bisector and say that angle 1 is congruent to angle 2. And then your fourth step, your final step, you'll be able to prove that angle 2 is congruent to angle 3, and you'll be using a property that lets you translate over that they're both congruent to the same thing and see if you can remember what that property is. I think you'll be able to get this one. All right, I'm going to complete this proof so you can fill this in along with me. This is the proof of the linear pair theorem. And if you remember the linear pair theorem, that is the theorem that says that, let me read it to you again, if 2 angles form a linear pair, then they are supplementary. So we are going to start by writing in our given into line 1. And you're going to write it just like it is. Yeah, it's a little bit long, but that's okay. It's okay to put words in proofs. Form a linear pair, and the reason is given. Okay, step 2. We are going to now say, well, what does it mean if they're a linear pair? So what does it mean to be a linear pair? It means that angle 1 and angle 2 form a straight line. I'm going to write that. Now, you wouldn't necessarily have to write this, but it is a straight line, right? So let's see, how could I write that? I could write that if they're a linear pair, then ray, it would be ray BA. Ray BA and ray BC are a straight line. Straight. Now this step is a little bit, like maybe you wouldn't necessarily need to put it in here, but I'm going to write every single thing. Because they're a linear pair, that means that this ray and this ray together form a straight line. All right, well, what does it mean if they're a straight line? That means that that angle ABC, is equal to, measure of that angle, is equal to 180 degrees. That's the definition of a straight angle. We learned that way back at the beginning, like 1.2. All right, so let's see. What do we got here? We've got that that's equal to 180 degrees, which is good because we know that supplementary is equal to 180 degrees. So that's my next thing. If measure of angle ABC is equal to 180 degrees, that means that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees because of the angle addition postulate. Angle addition postulate. Remember, the angle addition postulate says that this plus this is equal to the whole thing. Okay, that's good. Oh, actually, it would be equal to the measure of, I guess I can't say it's 180 degrees yet. I have to say it's the measure of angle ABC. And then I can say that I can substitute in measure of angle C equals 180. So then the next step, I would actually say that then that's equal to 180 by substitution. Okay, we almost have that they're supplementary now. The definition of supplementary is that their sum is equal to 180. That's the definition of supplementary. So now I'm able to say what I wanted to prove was that angle 1 and angle 2 are supplementary. And that's my last step. I don't need that last line there. So measure of angle 1 plus measure of angle 2 is 180. And that is the definition of supplementary. So now I know angle 1 and angle 2 are supplementary. Now, it's okay when you're doing a proof if you don't write every step the same as the way I wrote it. There's more than one way to do proofs. On this proof, you're going to have the given written down first. I'm not going to do that part for you. And then it says to use the linear pair theorem. Well, we just proved the linear pair theorem. The linear pair theorem says that if you have a linear pair, then they are supplementary. So we never have to do all these steps again because now we know the linear pair theorem says that if they're supplementary or if they're a linear pair, then they're supplementary. So angle 1 and angle 2 are supplementary by the linear pair theorem. So isn't that good? Now this step, you might need another step beyond what they have here. There's another theorem that says that, did I show you this theorem yet? I'm going backwards a little bit. Yeah, it's in the 2.7 lesson. It's on your worksheet, but I didn't paste it onto this PowerPoint. It's right here. This theorem says, 273 says, if two congruent angles are supplementary, then each angle is a right angle. If two congruent angles are supplementary, then each angle is a right angle. This is proved in your book. I forgot to write what page it's on, but it's on like page 120. So if they're supplementary and they're congruent, then they're right angles. We're going to use that here. Look at, we just proved that they're supplementary. It tells us that they are congruent. That's part of the given. So your last step is going to be this. You're going to be able to prove that, and you're going to use the theorem that I just showed you, which you might want to write the number for that one. This one doesn't have a nice name. 273 means it's in Chapter 2, Section 7, the third theorem. There's not a great abbreviation for it, but the theorem says that if two congruent angles are supplementary, which means that they are 180 degrees, they're sum, then each is a right angle. You could also prove this without that theorem by using like the division property. You could say that 2 times angle 1 is 180 degrees because angle 1 and angle 2 are congruent, so I could replace one's measure with the other, and then you could divide by 2 and you could get 90 degrees, which is a definition of right angle. But it would take you like 4 more steps if you didn't use this little theorem. Okay, so congruent supplements theorem. Let's prove this. The congruent supplements theorem we already looked at. We looked at the theorem. It said that if angle 1 and angle 2 are supplementary and angle 3 and angle 2 are also supplementary, then angle 1 will be congruent to angle 3. All right, so in this proof, we are going to start with our given. And our given is a little long. And then you write the other given down. There's 2 givens there. I'm going to write them both at the same time. Now, if they're supplementary, it means that their sum is how many degrees? And that's by the definition of supplementary. So write that for both of them. There's 2 of them. You have to write what that degree will be. Once you have that they're equal to that degree, then you can set them equal to each other with substitution. Well, if one of them is equal to 180 and the other one's equal to 180, you could either use the transitive property or substitution to say that then they are equal to each other. And again, you can either use substitution or the transitive property of equality there. And then number 4, step 4, we're going to subtract the same thing from both sides. See, there's the same thing, so we could subtract with the subtraction property. And then you'll have that the measure of angle 1 is equal to the measure of angle 2, and then we'll have to use the definition of congruence. The definition of congruence is when you have something, an angle measure is equal, then the angles are congruent, and that's definition of congruence. If you do those steps the way I said, you won't need step 6. You might add an extra step in there somewhere to maybe, I don't know, to write simplify or something, but you might not need that step. Okay, I think there's one more proof. Let me just review these theorems. Oh yeah, there's a proof of the vertical angles theorem is the next one. There's a theorem called the common segments theorem. It's pretty basic. It says if you have points A, B, C, D all in a line, collinear, then AB is congruent to CD. Oh, if AB is congruent to CD, then AC is congruent to BD. You could prove that without having to memorize that theorem, but it's kind of a handy little theorem. And then this is very important, vertical angles theorem. Vertical angles we already learned about. They're when you have an X. The 2 angles opposite each other are called vertical angles. And this theorem says that they're congruent. We will use that a lot, so we're going to look at that proof. A lot of this proof is already written for you. You have to prove that angle 1 is congruent to angle 3. You're given that they're vertical angles, so you write the given in. Step 2 is that angle 1 and 2, see these 2 here, are a linear pair. Also that angle 2 and 3 are a linear pair. That's the definition of linear pair. They are because they add up together to be a straight line. And then you've already used this before. The linear pair theorem says that if they're a linear pair, then they're supplementary. So that's your missing words there. And then we just proved a theorem that says that, let's look back a minute. We proved that if they're supplementary to the same angle, then they are congruent to each other, the congruent supplements theorem. So you're going to use, that'll be your reason, the congruent supplements theorem, in order to say that, well, if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, angle 1 and angle 3 are both supplementary to angle 2. They're both supplementary to the same angle. Therefore, using the congruent supplements theorem, you know that they'll be congruent to each other. So you'll be able to prove the last step. So hopefully you find this helpful and able to solve some proofs, finish some proofs, and good luck and keep trying and ask me if you have any questions. Thank you very much.